So we're going to begin by talking about what we call the measures of central tendency. Now we say that because truly these measures tell us what's the tendency of all of the values, what's happening in the middle. So the mean, as you probably already know, is also known as the average. And I'm sure you know that to find a mean, you add up all the values that you have and you divide by the number of them that there are, and that will give you the average. The median is the middle number of a data set. So you'd have to have your data in order before you could find the median. And the mode is the most frequent number, or the most common number. Okay, so just a really basic example here below. This is something you would have done probably back in middle school. Find the mean, median, and mode for the data. Okay, well, to find the mean, I'm going to have to add up all of those numbers and divide by the number that I have. So what I would do, if you're following along, pause the video and just add up all of those and divide. So when I added them, I got 70, and I counted out that there are 10 values. So if I divide by 10, I get that the mean is 7. Okay, so now for the median, I'm going to go ahead and reorder these numbers because I really don't know my median until I do that. So I would put 2, then it looks like my next biggest is 4. I like to kind of cross them off as I go. That helps me keep track. Then I have 5, 6, and I have 2 7s. And then 8, 9, 10, 12. Okay, so I've taken care of all of these. So now, again, what I think is the easiest thing to do if you can't tell by eyeballing it is start crossing off one on each side until you get to the middle. And so in this case, I actually have 2 medians, and usually what we do when that happens is we add them together and find their average. Well, I know that if I add 7 and 7 and divide by 2, I'm still just going to get 7. So my mean and my median are both 7. This was for the median. I didn't label it. And then finally, the mode, you can usually tell just by looking at it. I think if you look at the set of data, you see that the only one that repeats is 7. So our mode is 7. So it turned out that the mean, median, and mode were all 7. That means that must have been a really, well, we know that that was the most common value, and that really would tell you where the middle of that data is. Okay, so now we'll go and start talking about measures of spread. So what these tell us, they actually tell us a little bit more detail about the data because it doesn't just talk about the middle, it really tells us how spread out are the values. So we get a little bit more of an idea of the variability of the data. So the range is the simplest measure of spread, and you might remember this one too. You find the range by taking the maximum value of the data and subtracting the minimum. So it's literally just the difference between your max and your min. So that's a pretty easy, basic way to see how spread apart the values are because you can see how far apart the most extreme values are. Standard deviation is probably more of a new one. You might not have heard of this one before. Standard deviation, it actually tells us a lot more about how spread out the values are. There's a really long, complicated definition for standard deviation, but I think the easiest way to describe it is the average distance that a value in the data set is from the mean. So if you were to figure out how far all of the values in the data set were from the mean and average them all together, you would come out with your standard deviation. So that's why we can kind of break it down into categories. So if you have a really big standard deviation, that means there's a lot of variability, a lot of variety in your values. They're very spread apart, which is why that when you averaged all those differences, you still got a large number. A small standard deviation would tell you that there is not a lot of variety. So, similarly, if you took all of those differences and averaged them out, you're getting something very small, so they're all pretty close to the mean. And if you get that you have a 0 standard deviation, that sounds maybe kind of straightforward, but that would just mean that all of the values are exactly the same. There is no difference between all of them. That's why you're getting a 0. So all values are the same. That doesn't happen very often. Okay, so we're going to look at how we can compare standard deviations. We're not going to really worry about calculating it right now. That's not really that important. I want to more kind of compare how these standard deviations look. So here are 3 different graphs. We actually call these histograms. We'll be talking about these more. But you can kind of see that in this first one, the data is really, really grouped together. You have most everything is really close to, if we were to look at the scale, probably right around 100. This would be an example of a graph with a very small standard deviation because there's so little variability. So then if we move to the right, you can see this one does have a little bit more variety. You have more values that are starting to separate, even though the middle still kind of looks like it's right there at 100. This has a little bit bigger standard deviation than the first one. I'm just going to start calling this SD. And now this last one, this one really has a lot of variety. It does still look like the middle's right there around 100, but there's a lot more variation in the value. So this would have the biggest standard deviation of these three. So you're really looking again at how are a lot of the values near the middle or are they very spread out? That's what standard deviation measures. Okay, so now we're going to start looking at comparing some more of these histograms or distributions, another way to talk about it, and just seeing what we can figure out by looking at it. So part A in this question says, what's the mean of each? Well, we could sit here and list out all the values. We have the frequencies here on the left side, so it tells you how many times that value occurs. I could list them all out and add them up and divide the way I normally do a mean, but I think you can tell that because this is so symmetric and you're really centered very nicely around 8, your mean is going to come out to 8. You can assume that when you have that nice bell shape. So for sure, the mean of sample A is going to be 8, and even though sample B looks a little bit different, you still have a very symmetric distribution around the 8, so you can assume that they both have a mean of 8. Okay, similar with the median. If you take a look, the key for median is you have the same exact number of values on either side of your middle. So that means if we were to line them all up in order, 8 will still remain in the middle, and it's the same thing going on over here. Same amount of these values that are happening on either side of the number in the middle, which means that if you lined them all up, you would get a median of 8 on both. So both of these have a median of 8. Okay, now the range. So remember, we're looking at the difference between the max and the min. So for sample A, it looks like the highest value we have is 12, and the smallest is 4. So I get that my range is 8. So we'll do the same thing for sample B. Taking a look at our biggest value, it looks here the biggest is only 10. It doesn't go any higher, and the smallest is 6. So 10 minus 6, we only have a range here of 4. So the range is actually very telling. Obviously then, if the range is larger for sample A, that means there's more variability in sample A. So then I'm hoping that part D seems sort of straightforward. Which one has a larger standard deviation? Well, the one with the larger range. There's more variety in the values. So sample A, because the values are more spread out. You could also talk about the range if you wanted to. You could say because sample A has a larger range, which means that, you know, the values at the extremes, the highest and lowest, are larger. So that's just an example of looking at two very symmetric distributions and finding that the mean and median are very easy to pull out, and even the range isn't so bad. The reason those came out so nice, we call these distributions that have that nice symmetric shape. If you kind of can make a line over these, they both have that nice, we call this a bell curve shape. These would be called approximately normal distributions, which we'll be talking about more in the coming classes. But that's why we're getting the mean and the median like so nice and are matching up the way that they do. Okay, so the last thing I want to talk about is just the different types of distributions, and we'll be talking more about these in depth. So we just talked about how when you have that nice bell shape, you get some really nice things. You have that your mean is right in the center, and it's going to be the same value as the median. So anytime that happens, if your distribution looks approximately symmetric, you can assume that your mean and your median are going to be the same value. So again, we call this distribution normal, which we'll be talking more about. These are two examples of a distribution that's skewed. So when a distribution is skewed left, the way that I've always remembered that means it's skinny on the left. That's always how I've kept that straight, because some students always think that it'll be drawn the other way. So the skewed direction tells you where the graph is skinny. So when this happens, you have a lot more values on the right, which means that your middle value ends up being bigger than your mean. So your mean is going to have to kind of fall not quite in the middle, but close, because it's kind of averaging out those larger numbers with the smaller numbers, but the median, because there's more of the larger values, the median is going to be a little bit bigger. And then a skewed right graph, same idea. This one is skinny on the right. That's how I know that this is skewed right. And so here we have the opposite thing happening. We have more small values on the left-hand side, which kind of drags our median over a little bit. So in this case, your median is smaller than your mean. So the mean is still landing pretty much in the middle, but the median is to the left of it because there are more values over there. So if we were to line them all up, the median would land a little bit on the left. So these are our three basic types of distributions that we'll be talking more about and comparing.